Hello and welcome to this introduction to ProSap. ProSap is a software based on finite element method that allows to design concrete, steel, masonry and timber structures. After you have installed the program, you can open it with the link you find on your desktop. ProSap is organized in context and archives. In this moment is available only the first context, input data, where we can define the geometry of the structure we want to study. The other context will appear while we go on with the modeling. The archives are contained in this menu, structures data. The archives contains the information we want to assign to finite element. For example, cross sections of concrete, steel profiles, or also timber cross section. The archives of material contains the properties of the material you want to assign to finite element. There also is an archive of foundation that allows to model foundation element like plinth or piles. And there are the archive of design criteria that allows to give the program the information for the design, automatic design of the structure. For example, for reinforced concrete beams, the program asks the diameter of bars and the yield strength of the bars and the partial safety factor. To model a structure with ProSap, we can import a DXF file from AutoCAD or also an IFC file. ProSap also has a set of automatic generator of structures. For example, to model a concrete frame, we can use its generator of frames, select the typology of frame we want to model, and give the geometry of the frame, the height of the columns, the distance between the stories, and the length of the spans. So the program automatically generates structural elements. We can change the geometry of the frame the program automatically generates with the commands contained in edit group. For example, we can obtain an inclined roof selecting nodes, and using this command to stretch vertically our nodes and obtain the inclined roof. We save data. The next step is to assign the properties to structural elements. So the properties of structural elements, in this case columns and beams, are the following: the typology of a finite element, the cross-section, the rotation of the cross-section, the material, the design criteria, and also the release codes. It's also possible to assign alignments to model eccentricity of beams and columns. The properties must be selected from those defined in the archives. So the first thing to do is to define the archive of cross-section. For example, we define cross-section number 1 for columns, and cross-section number 2 for beams. We also set the number of legs for shear reinforcements. So we have to assign properties to structural elements. To assign properties to structural elements, we have to use this command, edit properties. With this command, we can read the properties of a structural element and change them. For example, we change the cross-section from 1 to 2, the cross-section we have defined for beams. To assign this property to all the other beams in the model, we can select the beam with this command, select by properties, asking the program to select elevation beams. Once the elements are selected, we can set the reference, so memorize these properties. And after the properties are memorized in the reference, we can assign them clicking on this black arrow and selecting assign reference to assign all the properties to the elements, or this command to assign just one single property. For example, assign cross-section. So if we try to read the properties of another beam, we can see that we have assigned the same section of the first one we have changed. The next thing we want to do is to assign boundaries to this model. ProSap allows to model rigid constraints, elastic constraints, or also to model foundation element. In this case, we select to model rigid constraints. We use always edit properties. We have to click on the node at the base of the structure and give in the rigid boundary codes. While we turn on the boundaries, a symbol appears on the node to advise the user that there is a boundary in that node. It's blue if the boundary just blocks translation, red if the node can't both rotate and translate. So, as we have seen for beams, to assign this property to all the other nodes at the base of the structure, we have to set the reference, deselect all the selected element, select all the nodes at the base of the structure, and use the command assign rigid boundaries to assign the property to all the other nodes at the base of the structure. When the model is completed, to go on assign loads context, we have to do this control, check structures data. It's an automatic control of the geometry of the model, where the program tries to find some problems like missing nodes, distorted element, and similar. If the check ends successfully, we can access the second context, load assignment. The first thing to do to assign loads at a structure is to define load cases. Load cases are groups of load of the same typology. ProSap also has an help that allows us to automatically define load cases. For example, we can ask the program to define automatically the dead loads, live loads, and the seismic load cases. When we ask the program to assign automatically seismic load cases, the programs ask us if we want to perform dynamic analysis or linear static analysis. We answer yes, because we want to consider a dynamic linear analysis on these structures. Now we open the archives of load cases to control what the program automatically defined for us. So the program defined the dead weight of the structure, the dead weight of roofs and floors, the live loads on floors, and the seismic action. Some of these load cases are automatic, so user doesn't have to give further information to the program. For example, the dead weight is automatic. The program automatically assigns loads in this load case according to the specific weight of material and cross-section of structural elements. There are some semi-automatic load cases. For example, the seismic load cases. The program can automatically model the seismic action on structures, but it needs a little information from the user. For example, the mass of the structure, the seismic zone, to define the response spectrum. And there are also non-automatic load cases. For example, this generic dead load and generic live load, in which the user must define manually loads on the structure. In this case, we are not going to use non-automatic load cases. It's an argument that we will cover in next videos. The second step is to define seismic load cases. We have to use this command, load data seismic load cases. In this moment we are using Italian regulation. So the program asks us the information to find out the response spectrum according to Italian standards. So we have to set the importance class of the structure, the seismic zone, the foundation soil category, topographic category. It's also possible to import a seismic response if necessary, instead of taking those proposed by the regulations. We have to set the behavior factor of our structure. There is an help, so we have to set the utility class and the regularity in plane and elevation. After we have done this, we can use this help to automatically find out the behavior factor to assign to our structure. In this case, according to Italian regulation, the behavior factor for this concrete frame is 3.9. We want to do a dynamic analysis, so we have to select a number of modes to consider in the analysis, for example 9. And at least we have to define seismic masses. There is an automatic definition that we can use. The last thing to do before to run analysis is to define load combination, load data combination. The program automatically defines load combination according to the regulation. We have to pass these general settings. that asks us some information about live loads, the duration of the loads for timber structures. In this case, we are considering a concrete structure, so this step is unnecessary. And the last step are the partial safety factors to assign to the loads. So, using this command, the program automatically defines load combination. The first one is for load combination with dead and live loads. The second one is for seismic load combination. This command provides the load combination for fire-bearing capacity. So if we haven't to do this kind of analysis, we can skip this command and define the combination in serviceability limit states. Okay. Once the combinations are defined, we can run the analysis. This command, after the end of the analysis, allows us to control the results. The first one allows to control the results for a single load case. For each load case we have defined. The second one is the command to control results in load combination. The last one is to control the results of dynamic analysis. We choose, for example, the command to view load combination. We select one of the load combination we have defined, and we can control the deformation, the deformed shape of the structure. We can control the action on the rigid boundaries we have defined at the base of the structure. We also can control the action on structural elements, for example, bending moments. We can change load combination to check these results even in a seismic load combination. This command, maximum and minimum, allow us to find out in which load combination we have the maximum or the minimum value of the results we are checking. For example, clicking on maximum, the program will show me the load combination where I have the highest value of the bending moment. If the results of the analysis are good, we can go to the last context, assign design data, and try to automatically design the reinforcement on structural elements. So we have to select the element we want to design, for example, all, and use this command, context, perform design, limit states. The program will automatically find out which reinforcements are necessary according to the regulation, Italian regulation or Eurocodes. In this case, we have some unverified elements. To control the results of the design of the structure, we can use these commands. The first one is for the beams and the second one is for the column. The first results we have is the design status. The blue element are verified, the red element are not verified. Then we have the results of single checks. For example, this is the result of the check to axial action and bending moment. The results that the program shows is the ratio between the action on structural elements and the resistance on structural elements. So the demand on capacity. So if the number in map is lower than 1, it means that the verification is satisfied. Elsewhere, if the number is higher than 1, the safety check is not satisfied. The other results are the check to shear and torsion on structural elements. And the program also showed the diagrams of the reinforcements, the amount of reinforcement that is necessary for safety checks for loads. We can also investigate the single element with this command, check, and clicking on the element we want to study, we can have further information about safety checks. So we can see the result of the check we have just seen on the map, but also the load combination where the safety checks are performed, the design action acting on this element, and some partial results, for example, the coefficient that enter in the formulas to estimate the resistance of structural elements. With this command we can investigate all the cross-section of the beam in this case we have selected. For the columns we have the same results. So the design status that show us in red the element that have not satisfied the safety checks, and the results of safety checks for bending moment and axial action, shear action, and also the joint, the safety check of the joint between beam and column. The program also allows to automatically generate structural drawings. With this command, generate drawing, you can obtain automatically the draw of the beam and the columns, and we can export in DXF format. And the same thing for the column. The program also writes automatically the calculation report in Italian or in English. The program can also create automatically some images to attach to the calculation report to clarify the safety check performed. Thank you for watching. Please subscribe to our YouTube channel to not miss all videos about ProSap.